In this algebra video, we're in Chapter 5, Lessons 1, 2, and 3, solving one-step and multi-step inequalities. You might be thinking, hey, this is 3 lessons at once. But I'm going to tell you that's because 90% of what you're doing, maybe 80%, is the same stuff we've already learned with solving equations. So our objective is, as the student, I can solve any basic inequality because I will use all of my regular equation skills. And, by the way, this is the special rule, and I'll remember to flip the inequality sign when I multiply or divide both sides by a negative number. By the way, that's the special exception you need to remember. So now, those symbols that are inequalities, the word inequality, the prefix in, un, that means not, or non, it means not. Equal, like an equation, they're saying not equal. And in other words, everything we're used to doing with equations, like 2x equals 10, that means the left side equals the right side. But we're saying inequalities, meaning not equal to. So those symbols are less than, greater than, less than or equal to. That's what that little line means, greater than or equal to. And technically there's a redheaded stepchild, one that never gets mentioned, but he does exist. And here he literally is unequal, meaning not equal to. He's an equal sign with a slash through him. That's the not equal to symbol. So, like I said, inequalities are solved just like equations. So take a look at this example on the left. You're going to recognize these steps of how it's done. I'm going to go ahead and show you. So you'll notice those steps of how I move things, how I move that -5 to the other side, how I move that ×3 coefficient to the other side. We recognize those skills, those properties of equality, except now they're called properties of inequality, but it's exactly the same, how to move something to the other side by its opposite, or its inverse, or the thing that undoes it. The only difference is, instead of dropping down an equal sign each time, we were dropping down the greater than symbol each time. So it solves just like equations. Now, except there's only one exception, and that exception is what it's so important I put it in the objective so you would always have it, and that exception is, what happens when you multiply and divide both sides by a negative? So first, let's do the first step of this inequality, solving it, just like we would an equation. Go ahead, pretend that's an equal sign if you need to, if that helps. So at this step, we recognize what we did before this, moving that +3 to the other side by doing the opposite. But now here's where it gets different. We're about to get rid of a coefficient. We always get rid of coefficients by dividing. Well, our coefficient happens to be -4. So we show our work the same way by dividing both sides by -4, and they still cancel just like before, but here's what's different. Yeah, x, yeah, on the right side, negative divided by negative is a positive, it's +6. That's great. But here's the thing, the special rule kicks in, and that special exception was in your objective. When you multiply or divide both sides by a negative number, you flip the inequality. So instead of being less than or equal to, it's going to become greater than or equal to. So the answer to this question is x is greater than or equal to 6, not less than or equal to 6. That's the special rule. Now, if you're ever unsure why, or if you're unsure of, we'll get to why in a minute, or let's say you're unsure of how, or did I do this correct, or I'm not sure. Here's the thing, just like equations, you can plug in your answer and check. But here's what we're going to do. Because it's an inequality, we want to pick a fence, because we're trying to decide, was this less than or was this greater than 6? So here's what you'll do. You'll plug in a number on both sides of 6. So maybe plug in 5, then plug in 7. So if you put a 5 right here, let's imagine there was a 5 there. Oh, wrong spot. I meant for x. Let's say there was a 5 there. -4 times 5. Well, that's -20. -20 plus 3 is -17. So we would have -17 is less than or equal to -21. Well, that's a false statement because -17 is greater than -21. So that is a false statement. So you know +5 cannot be your answer, which means this cannot be less than, x cannot be less than 6, because that means 5 should have been a solution, but it wasn't. So, but if you plug in 7, you'll get -28 plus 3 is -25, so you get -25 is less than or equal to -21, and that's a true statement. -25 is less than or equal to -21. So 7 totally works, which means the solutions are on that side of 6, which means greater than 6. So you can always check these. But the special rule I want you to keep track of is that inequality flipped simply because we multiplied or divided both sides by a negative number. Some of you might be wondering, why inequalities all of a sudden? Or why do we even care about inequalities? Because everything we've been doing up until now has been equations when it's been equal to something. And that's what I'm going to show you. So I took a moment to write the most common phrases that are used for inequalities. And you'll be honest, you've heard phrases like these in word problems or in the real world. It's not always saying something is something or equal to something. A lot of times they'll say, for example, you've got $50 to spend. That means at most, you could spend $50. So when you have questions like that and you're trying to figure out what you can spend, those are technically all less than or equal to questions, because you're welcome to spend less than $50 or you can spend exactly equal dollars, $50, but you cannot spend $51. That would not be, you don't have enough money, you only have 50. So that's an example. Many problems actually are inequalities using these common phrases. So in word problems and when you're out solving situations, look for these phrases. These are indicators that it's technically an inequality. So that's why we're doing inequalities all of a sudden. So very common, if you're given a word problem and your job is to write and solve the inequality, you're going to look for these words to figure out what symbols to use. The rest of it's going to be exactly the same like we're used to. When to multiply, when to divide, add, subtract, things like that. By the way, take a moment to write most of these down. Real fast, you don't have to write this down, but if you're one of those students that sometimes forget which symbol is which, less than, greater than, less than, if you suddenly forget, a fast way to remember is, I took a quick picture of my hands, hold your hands out like this and look at those symbols that they make. You ask yourself, which hand do more people in the world use? Do more people, and feel free to hold your hands out, do more people use their right hand or more people use their left hand? And you already know the answer to that. It's more common for people to use their right hand than it is their left hand. So this is the greater than symbol because more people use their right hand. That's one way. The other way that some people like to call it is actually look at the symbols. The less than symbol looks like an L, L for less than. The greater than symbol, you can make it look like a G by adding that little piece right there, G for greater than. So because that one turns into that. I got that one from a student last year, I believe. But yes, this is two ways from remembering how to do less than or greater than, which one's which. How can we write our answers? Our choices are set builder notation, which I'll explain in just a second. Wait, sounds fancier than it is, or a number line. So for example, look at this example. It's funny when I say that, sorry. Anyways, so you'll notice, yes, we can, just like equations with the variable on both sides, you can have inequalities with the variable on both sides. You're still going to use the same thing we talked about before with the mutant chicken method. Feel free to check out my video on solving equations with variables on both sides. If I remember, I might stick the link to it in here if you need help with that. Anyways, we should, hey, I'm going to change this question slightly. Let's make it a little bit harder. Sorry, I just want to make it have a 2 steps after we move it. Anyways, we should move our variables to the same side first. So let's move the smaller one like we said in the mutant chicken method. The smaller one is positive 3x, the opposite is negative 3x, so subtract. So subtract 3x on both sides. Now, by the way, I'm showing you, we're going to write our answer in both of these formats to show you that's why I'm doing it through example. Anyways, you'll be left with 8 is greater than or equal to, that's 2x. Now, here's the thing. We only have one step remaining. We got to get rid of that coefficient of 2 by dividing. Now, it's positive 2, so we're not activating any kind of a special flipping inequality or anything like that. So we're left with 4 is greater than or equal to x. Now, that's great and all, but here's what I want you to get in the habit of doing. I want you to get in the habit of always writing your answers with your variable on the left and your whatever number on the right. And to do this, to flip this properly, it's very simple. You literally, because look, notice, we just flipped the entire thing. This is not any special rule or anything. This is how to write the equivalent. Notice, the alligator is currently eating the 4. The alligator always wants to eat the big one. Those were supposed to be teeth, but now it looks like fire. Anyways, the alligator always wants to eat the bigger number. So when you flip everything just for the sake of making your life easy, the alligator should still be trying to eat the bigger number. So these two answers mean exactly the same thing. We haven't done, there's no special case happening here. I'm just showing you. We want to get in the habit of writing with our letter on the left for what I'm about to show you when we use a number line. It's a lot easier to do it consistently without getting confused if you always put your letter on the left. But both of these answers do mean the same thing. Alright, so first I'm going to show you this fancy so-called set builder notation. Basically, it uses what we talked about before with sets of numbers. being inside of these brackets or braces. I believe they're brackets. Or are they braces? I always get it backwards. It doesn't matter. All right, so set notation looks like this. Because we were using x, we say x, big bold line, and then we actually write our answer how we wrote it. We say x is less than or greater than 4. Now, this looks fancy, but basically what this is saying, let's translate this into words. This is saying the set is all numbers of x, okay, all numbers x, such that, this is such that x is less than or equal to 4. Now, I admit this is kind of cheesy, but I want you to know what it means because you're going to see this. Very often you'll also see it in this format. Instead of an x in there, you'll often see this symbol. It's basically a fancy looking R, and it means all real numbers. And this would be read that the answer is all real numbers such that x is less than or equal to 4. Sorry, I keep mispronouncing that. So in other words, it's just saying the answer is everything smaller than 4, including 4 because it says or equal to. But very often you see it written that way. So I just want you to know what those symbols mean. However, mathematically, I care most that you're finding this inequality. For our purposes, that's basically all we need. Now let's talk about the number line. Here's my fancy number line. Drawing the number line is very, very fast. But okay, let's take a moment to talk about graphing our answers. First, I'm going to go ahead and just graph this answer so you can see it. Then I'm going to explain why. The way we would graph this answer would look like this. And again, I'll explain the parts why in just a second. Notice that's a solid colored in circle. That's going to be important. It's shaded to the left. Now, this shading can be done on top of the number line. Very often you'll see it as just gray shading on top of the number line. I like to get in the habit of doing above. It's a personal preference. That way if you need to erase it or change it, you're doing it in pencil. That way you're not accidentally erasing your number line when you go to fix your mistakes. So I like to put it above it. Okay, so now let's talk about what this means, how we put our answer. Basically we're saying, because we said the answer is everything smaller than 4, meaning less than or equal to 4, we said so if the answer is everything smaller than 4, that means basically everything to the left of 4. Everything over here is an answer. Well, everything over here will make it true. Remember, inequalities are for ranges of solutions, not just one number. So everything to the left. But now, so that's why it's shaded to the left, because it says less than. Think of that less than as an arrow pointing to the left. But notice, this only works if you get in the habit of if we have less than or greater than, so what I have over here, that's going to be an open circle. And that's because the answer does not include whatever this number was. So if this is just said less than 4, that means it would not have been including 4. But if you have that or equal to down there, or the or equal to down there, that means it does include the other number. So when you graph it on the number line, you're going to use a solid colored in circle. That's the difference, because 4 is your boundary number, but when you just have less than or greater than like these, it doesn't include 4. But when you have these, it does include 4, and that's why we're going to color it in. And that's why this one was colored in, because it was or equal to. So keep track of that. Is it shaded to the left or shaded to the right? And is it a solid circle or is it an empty hollow circle? And you'll use your determination based off of, if as long as your letter's on the left, if it's less than, you shade to the left. If it's or equal to, you fill in that dot. Those are the only two things you need to know. Let's keep track of those, because we're going to get in the habit of graphing some of our solutions. Give this one a shot, and yes, you'll have to use the distributive property. But go ahead and solve this one just like you would an equation, but keep track of any special rules with flipping of inequalities, hint, hint, or anything like that. Solve it, and once you do it, I want you to graph your solution on a number line, just like we did in our last example. Graph your solution on a number line. Give it a shot. Hit pause. Alright, let's distribute. 2 times negative 3m is negative 6m. 2 times negative 5, positive times negative, that's a negative, so you put a minus sign. 2 times 5 is 10, so in other words, negative 10. Now drop everything else down. Now, you've got yourself a two-step equation. Let's get that minus 10 out of there, then we'll get rid of that negative 6. Alright, so from here, you got to get rid of that coefficient. So you're going to divide both sides by negative 6. Oh, hey, special case. You just divided both sides by negative. So you're going to have to remember to flip that inequality sign. So we're going to have m something. Negative divided by negative is a positive. 18 divided by 6 is 3. But now, special rule, because we divided both sides by negative, this has got to flip. So it's going to become less than or equal to. So m is less than or equal to 3. That is your solution to this question. Now, I want you to go ahead and graph it. But before you graph it, let's make the healthy habit to check our answers just like we did with equations. So if you think it's less than or equal to 3, so what you want to do is let's test it by plugging in something that's on the true side of what we think is 3. So something on the true side would be 2. So let's plug in 2 into our equation. Now, to save ourselves effort, we could plug it in here, we could plug it in here, plug it in one of them, but plug into the original in case maybe you made a mistake. So you plug in a 2 there. If you do that, you'll get negative 6 when you multiply those together. So if you get negative 6, that's negative 6. Negative 6 minus 5, well, that's negative 11. So the inside of this parentheses all equals negative 11. So if you do that, you'll have 2 times negative 11. Well, that's negative 22. So you have negative 22 over here. So you have negative 22 is greater than or equal to negative 28. And I know you're going to have to remember your negatives, but that's true, meaning it's further to the right. Negative 22 is greater than negative 28 because it's further to the right of the number line. So it turns out 2 was our solution. And let's say you still weren't sure. You could plug in something on the other side of 3, or you could plug in 3 and go all about it. But we're good once you check your solution. So now make your number line. That number line took me about 5 seconds to draw. So once you've done that, graph your answer. Make sure you graph it correctly. Take a moment to think about it. Is this going to be shaded to the left or to the right? Okay, that's great. Or maybe you should ask yourself, is this going to be an open circle or a closed circle? It has or equal to, so that means the answer includes 3, so it's going to be a closed circle. All right, so closed circle. And I may have given away my number line the way I drew it, but less than, that means it's everything smaller than 3, so yes, we are going to shade to the left. So draw an arrow and shade it in going to the left. And so you now have solved, checked, and graphed your solution. Great job. Keep going. Give this one a shot. And just make sure to keep track of everything, just like you would an equation. Alright, so we can assume that we pretend there's parentheses around that because it says everything up there divided by 5, meaning the last thing you would do is divide by 5. So because of that, that's the first thing you undo. Well, the opposite of divide by 5 is times by 5. So you multiply both sides by 5 to move that. So those cancel. I'm going to go ahead and not cross them out, that gets sloppy. So if we do that, we are left with, drop everything down, and you'll be left with this. So now you have a two-step equation going from here. Go ahead and finish it just like you normally would. Uh-oh, we're dividing both sides by a negative, so remember to flip the inequality. Positive divided by negative is a negative. 45 divided by 3, well, that's 15. We said we had to flip the inequality. So it's f is less than negative 15. And feel free to check your answer. Now, if you're going to graph this on a number line, think about it to yourself. Is this going to be an open circle or a closed circle? We see it's just less than. It's not or equal to, so it's going to be an open circle. It's less than, so we're going to shade to the left. So it's going to look like this over 15 on the number line. There's my quick number line. I'm coming back here to remind you, remember, everything solves just like equations. So just because I'm not giving you examples of a bunch of negatives or a bunch of decimals or a bunch of fractions, all those things we learned about those things in Chapter 2 of this year and Chapter 3 of last year, all those things still apply. How to combine fractions, how to deal negatives, how to move things to the other side. Everything is the same. I don't want to make this video hours long because they include all possible ways I can ask it, but I'm going to tell you, every question is basically the same thing. You're going to solve, get your letter by itself, but just keep track of your inequality. You only flip it when that special rule pops up. So I'm going to give you a couple more examples where I'm just going to let you kind of solve them. I'm not going to put a lot of explanation into them, but at least want you to give them a shot so you know you're ready. But real fast, let's make sure you remember how to make this the bougie answer using that set builder notation, because I don't want you to get surprised if you see this on a test or a quiz. That's it, just like that. The answer is all numbers of f such that f is less than negative 15. Keep in mind also, I'm not including a bunch of word problems here, but like I said, when doing word problems, you're just going to look for these common phrases in them, and you'll translate and then do the operations like we always have, and then solve. So everything we're doing is cumulative. Your last two examples are going to be special cases. So I want you to pay special attention to what happens to them. Basically, it's going to use the same rules we learned before. When solving, if your variables all cancel out and you're left with a true statement, The answer is all real numbers. If you're solving and your variables cancel out, you're left with a false statement. The answer is no solution. But let's see what this looks like with inequalities, and I'll make these your last examples. Work your way through this one. Distribute, combine like terms, then start solving. Notice that's plus 6 down there because a negative times a negative is a positive. Now drop everything else down. Okay, so now you dropped everything else down. Look for any like terms. And you do have like terms on the left side, so get those combined before you do anything else. 18 minus 12, well, that's 6. Now this left side and right side are starting to look a lot like each other, hint, hint. But if you haven't noticed yet, you would just keep going from here. And you would move your variables all to the same side. You don't know which one to move because they're the same size, but that's okay. We would add, so add 24c to both sides. Well, here's what's going to happen. They're going to cancel on the right side. They're going to cancel on the left side. And notice your letters all canceled out. This is going to be one of those special situations. So you're left with 6 is greater than or equal to 6. Now, if that or equal to had not been there, then yes, this would have been a false statement. The answer would have been no solution. But because that or equal to is there, this is a true statement. It checks out. So our answer is all real numbers, or technically we can write it the bougie way. If you see these brackets, you could say the answer is all numbers C such that C is all real numbers, or C is a real number, meaning basically everything. That's what they're saying. That's a solution to this inequality. You obviously can't graph the solution on a number line. Alright, so let's give this one a shot. Distribute, combine like terms, start solving. Hint, hint might be a special case, but let's watch what happens. At least see how far you can get it. Now drop everything else down. Now once you do this, your job is you should be combining like terms. Well, we have 8m minus 8m. Those are like terms. They're on the same side. Now, they don't have to be on the same side to cancel out. Oops, I gave it away. But they are going to cancel out. 8m minus 8m, well, that's 0. Poof, it's gone. Because 0 minus 20 is just negative 20. So we have negative 20 over there, less than or equal to. So we're left with 46 is less than or equal to negative 20. Well, I think you'll notice that is a bunch of phooey. That is a false statement. 46 is not smaller than 20. So when you're solving inequalities, just like with the equations, if your variables cancel out and you're left with a false statement, you've got yourself no solution. So the answer to this is, it's super fancy, nice and bougie. What goes inside of our brackets is the symbol for nothing, the symbol for null set, N-U-L-L, null set, meaning empty. In other words, there's our symbol. It's like a 0 with a slash through it. That's a Greek symbol for 8, nothing. Alright guys, so what we've now done is this. We have, I explained to you in the very beginning, let's go all the way back, is everything we're doing is just like equations. Only thing is, remember the special case when multiplying and dividing both sides by a negative. We're talking about inequalities, which are things when the left side is not equal to the right side. I gave you some examples. They solve just like equations. That's why I didn't want to spend a lot of time doing all these sections. We're going to focus on the what to do with inequalities, and we're going to do some word problems with them as well. But we're going to do those in class. But this is your introduction to it. Now, talk about those common phrases that you need to keep track of to know when a word problem is doing what. And I helped you remember which one is which if you ever forget. And we did some examples. We did set builder notation, number line. I talked about when to shade it in, when not to shade it in. This example, we did it. We shaded in because it was or equal to, and it was shaded to the left because it was less than. Then you tried one on your own, and we put in set builder notation. I think I remember putting a janky highlighter number line for this one, but I must have erased it. Same thing here, special cases. Just remember, if you're left with a true statement, all real numbers. Left with a false statement, no solution. Alright guys, study, take good notes, and make sure they're detailed, and come to class, and we'll do a variety of these practice problems, have good quality questions if you're a little bit confused, but come prepared, and we'll take it further. We'll do word problems, we'll do a little bit taking this one step further. Take care.